In the workshop, a Markie traction engine. This is part 7, the final part, fitting a new water gauge glass, general reassembly and a final steam test before boxing it up to post back to the owner. This water gauge was really badly blocked with lime scale, but even when I unblocked it, the fit of the glass in this water gauge was far too tight in my opinion. I'm really not used to this, there has to be a little bit of play normally, but the glass is so tight in this gauge, as I tightened the bottom nut, the glass fractured. So there's nothing else for it. I took off both of the fittings and took this opportunity to clean up the backhead at the same time. And then I drilled out the fittings slightly with a 4.5mm drill, bearing in mind the glass tubing is 4mm in diameter. All that remains to be done now, with the help of some Loctite 542, is to fit the water gauge back in place, and then put the glass in and put the nuts on at each end with the rubber washers. And now when I fill the boiler with water, I can see the water level in the boiler, so everything in the water gauge area is now sorted. I've videoed this next bit especially for Chuck, who's one of my Patreon supporters. He asked me to make sure that I cleaned the brass wheels before I put the guard back on, so I did what he requested. And then I refitted the back wheel, then I lit the gas burner, and here it is, glowing merrily in the firebox. As always, while the burner's doing its stuff and heating the water, it's time to go around the engine with the oil can. And after about 10 minutes, with the regulator open, I gave the flywheel a push and off it went. And as before, it's very gurgly at the moment, but once the engine runs for a while, everything will get nice and hot and it stops gurgling. After I fitted the replacement spring, I set the safety valve to blow off at 50 pounds per square inch. And as you can see, it's now blowing off at 50 pounds per square inch. The last spring wouldn't have done this. It would probably have blown off at about 300 pounds per square inch, probably blowing up the boiler in the process. I cannot stress enough how important it is with model steam engines, even small ones like this, to make sure that the safety valve blows off at the correct pressure. Even though I would classify this engine as a bit of a steam toy, it could do a lot of damage to the operator if the boiler was to explode. So please heed my warning and always be very careful where pressure vessels are concerned. I'd also like to make one important point about the gas burners like this one that's used in the engine. This is a Bix burner and it's very easy to cremate them if they get too hot. So once you've raised a bit of steam, turn the burner right down. You don't need a lot of gas to keep this thing going, so it's a good idea just to keep the burner turned right down. If you overheat the burner, first of all it will make a popping sound that gives you a clue that it's overheating, followed by a roaring sound, which means that the burner is cremating the piece of ceramic on top of it. So if you hear either of these sounds, turn the gas off immediately and give the burner a minute or two to cool down before relighting it and turn the gas a bit lower. This seems to be a very common problem with Bix burners, and I think it's the type of ceramic that they use. I've done everything by the book, so to speak. Phil at Forest Classics, where I bought the burner and the tank from, said that I should use a number 8 gas jet, which I have done. But when I turned the gas up too high, the burner still overheated. I've moved the gas jet further into the Venturi pipe, and this seems to make it a little bit more forgiving. If this situation continues, then maybe a smaller gas jet is a good idea, but it should be okay. It's running fine for me here in the video, and I ran this for about half an hour or so. There's no way of filling the boiler on this whilst it's running, so you can only really use one pot full of water, then you have to stop the engine, let everything cool a little bit, refill the boiler, relight the burner, and the cycle starts again. And in between that time, of course, you would have to refill the displacement lubricator and lubricate the moving parts of the engine anyway. What I'm trying to do in this clip is adjust the regulator so that the engine runs at just the right speed to make the traction engine rock back and forth, just like the full size. I'm going to slow it down and you'll see it happening. Running in slow motion, you can clearly see that the traction engine is rocking back and forth, just like the full size. And this is due to the reciprocating mass of the piston rod, the crosshead and the connecting rod. And that's it from me on this one. I'm just going to leave you with the engine running so you can get a really good feel of how good this little engine is. Thanks for watching, and I hope you found it useful.